Kids, hey, see if you can find this in your packet. It says Introduction to Rotational Kinematics, Part 1. Okay, here's what this is really all about. Okay, when you are first studying kinematics, we talked about, hey, 5 meters per second is roughly 10 miles per hour. Why is that important? So that if you get, hey, you have a person that is running at 20 meters per second, you could go, well, wait a second. Unless that person is Superman, that doesn't make sense because that would be like a roughly 40 miles an hour. And that doesn't work. Well, it's going to be the same thing with this. It is important that you understand what a radian is. It is important that you understand if something is spinning at, for example, we'll talk about this, 3 radians per second. What does that mean? Like how much are they actually, spinning around? That type of thing. Okay, so first of all, hopefully you know this. Maybe you do, maybe you don't, but here's what a radian is. A radian is defined as this is the radius, okay? It's the angle that you sweep out when the arc length is equal to the radius, okay? Which it's going to come out to be, you know, about 57 degrees. Now, how did I get this? Here's what you need to understand. One time around the circle, all the way around the circle, is 360 degrees. Okay? 360 degrees. Okay? One time around the circle, all the way around the circle, is 2 pi radians. And as long as you know that, you can do everything in this unit. Okay? So 360 degrees, 2 pi radians. Well, if I take 360 and I divide it by 2 pi, do you guys see what I did too there? I put parentheses around that. If you just type in this, here's what the calculator is going to do. The calculator is going to take 360 divided by 2 and then multiply by pi, which is why you get this gigantic number. Well, that's not what I want. So, let's use good um, order of operations here. But it comes out to be just over 57 degrees. So 57 degrees, if I was to draw that out, okay, that is roughly something like this. Okay, so this would be, okay, 1 radian, where again, the idea is, so this is like 57 degrees, which is equal to 1 radian. Okay, this arc length would be equal to the radius. Okay, so it says if you're to do 2 radians, it's going to be roughly over here, and you guys can measure that out. Do this. If you were to make a half a rotation, so if you were to go like this, that would be pi radians, okay, which is just over 3. So if you are spinning at 3 radians per second, you are making a half a revolution about, okay, every single second. So it would be like, you know, whatever, but it's spinning, so it'd be like, hey, that would be pi radians, okay? And then after 2 seconds, it would spin almost one full length around, okay? Because a full length around is going to be 2 pi, 6.28 radians. So if you're going roughly 6 radians per second, you're going about 1 rotation every single second, okay? So that's important. Okay, so you guys can fill that out a little bit more in depth. You can pause it and fill it out more in depth. But if you look at this page, okay, so now if you have a bunch of people here playing Crack the Whip, so they are going to be, spinning around like this. So they're going around in a circle. Okay, well, it says if the person on the outside makes a full revolution, what distance do they travel? She travel that she is going to travel 2 pi r, like the distance is going to be 2 pi r because it's the circumference, which is why she's going to travel a bigger distance than this person and this person, and this person doesn't travel any distance. Okay, if the person on the outside makes one full revolution, what is the angle they sweep out? Okay, it would be 2 pi radians. So the distance would be 2 pi r. The angle would be 2 pi. This is super duper important because you can see there's a relationship there. Okay, and that's going to be something we're going to be coming back to. Who's moving the fastest? Well, duh, the person on the outside is moving the fastest. Why? Because they're moving the biggest distance in the same amount of time. Everybody's going to be traveling the same amount of time. How would you calculate the speed of the person on the outside? Well, how would you do it? Well, you would say, well, this is equal to distance over time, which is going to be 2 pi r over the time. If they're going around one time, then it would be a special time called the period. How do you calculate the angular speed? Well, the symbol for angular speed is omega. It would be theta over t, which would be 2 pi over t. Hey, again, do you see the relationship? See the relationship? That's going to be super duper important. Okay, which person would have the highest angular speed? Well, they're all sweeping out the same angle in the same time. You know, if you look, do you see how they all swept out? That would be pi radians when they get to here, and they all went the same exact time, so they would have the same. What are the 3 ways to accelerate? Well, you have to change velocity. How do you change velocity? You could speed up, you could slow down, you could change direction. So remember, if you're moving at a constant speed in a circle, you are accelerating. Why? Because you are changing your direction. Remember, that was centripetal acceleration, which was linear speed squared divided by the radius. Okay, hopefully you remember that. Well, what are the ways to experience angular acceleration? Well, if the ways to have acceleration is to speed up, slow down, or change direction, well, it's going to be the same thing. Rotate faster, rotate slower, or change the direction that you're rotating. Okay? So if the person was moving at constant speed in a circle, what is their angular acceleration? And the answer is there is none. Okay? So this is an example where, yeah, you know what? You can have a linear acceleration, but you won't necessarily have an angular acceleration. Okay? All right. Then if we flip to this page, and this is, again, going to be important stuff, so make sure you are, following along and take some notes here. But displacement is how far you are from your starting point plus the direction you went. The units are meters. Well, theta is going to be defined as the angle swept out, okay? Plus, and it's really angular displacement. That's what this is. So this is angular displacement. Okay, but it's the angle swept out plus the direction. Well, how do you do direction? Well, for our purposes in this class, your direction is either going to be this way, that way would be counterclockwise, this way would be clockwise. Okay, so plus the direction, and the direction would either be clockwise or counterclockwise. Okay, units would be radians. Okay, average velocity is your displacement over time measured in meters per second. Well, your average angular velocity or average rotational velocity, either one, and the symbol for it is omega, like this. It's kind of like a script W. Would be your angular displacement over time. Your units would be radians per second. The direction would be which way you're rotating, and it's either going to be clockwise or counterclockwise. Okay? Acceleration is defined as the rate your velocity changes. So remember, I have this really sweet car. My sweet car goes from 0 to 60 miles an hour. You're not impressed? All right, you want to know how much time does it take? Does it take 10 minutes? Does it take 10 seconds? There's a big difference there. It's the rate your velocity changes. Well, angular acceleration, and the symbol for it is a Greek symbol alpha. Okay, or if some people call it fish, but it's the same deal. It's an alpha. It rather than the rate it's going to be the rate your angular velocity changes. Now, whenever I'm saying angular velocity, feel free. You can always say rotational velocity, same difference. So it would be this would equal the change in omega over time. Okay, the rate your angular velocity changes. The units would be, well, it would be radians per second per second. Okay, where this is meters per second per second. Okay, this would be radians per second per second. Or if you like, radians per second squared. And then the direction, again, it's going to be the same, where here it's the same direction as the net force. This is going to be the same direction as the net torque. Okay. And again, our net torque is either going to be clockwise or counterclockwise. Okay, so we're always going to be coming back to that. All right, our formulas. Okay, and if you look on your formula sheet, okay, there's actually only two rotational kinematics formulas there. They give you three linear kinematics formulas. I don't know why they don't give you three rotational, but honestly, we had these five kinematics formulas. So let's just do the rotational equivalent to those five. That again, this is super easy. All you have to do is just change the variables. So it's like, all right, well, I have V. What's the rotational equivalent to V? That's omega. Okay. I have VO, so then I'm going to have omega 0 plus, instead of A, I would have alpha. Okay. Same difference. So it's just where this is final velocity equals initial velocity plus acceleration times time. This is final angular velocity equals the initial angular velocity plus the angular acceleration times time. Okay, it's that easy. So let's transpose this one. Now remember, on your formula sheet they have it's really x minus xo because they're saying position, where we said x is just displacement because I think it's easier. So we're going to do the same thing here, that you'll notice on the formula sheet they're going to have theta and theta 0 because they're talking about initial angle and final angle, but we're going to just say angular displacement. So we're going to say theta equals, and then see if you can do the rest. So pause it and see if you guys can do the rest, because you'll need to be able to do this. This is an important skill to have. So pause it and then we'll come back. All right, you paused it. Did you pause it? Did you? All right. So let me just show you for these. This one would be omega squared equals omega naught squared plus 2 alpha theta. This one would be theta equals omega, like final. If you want, I can put a final there. Minus t minus 1/2 alpha t squared. And then remember, this formula is just average equals average. This formula is not there, but this is just average equals average. So if I want to do average equals average. Okay. And then the last thing down here is, this is super duper important, and we're going to be coming back to this over and over and over again. But here's what you're going to do. This is connecting the linear to the rotational. So here's what you're going to do. You are going to draw a circle. All right, everybody draw a circle. And then we're going to say, all right, the distance to go around a circle one time is 2 pi r. The angle to go around a circle one time is 2 pi. So then if I want to connect these two, okay, if you look, well, I have to take this times r to get this. So that would mean d equals r times theta. Okay, does everybody see that? Or theta times r, however you want to write it. Well, same difference. If I go omega, like average, is distance over time, well, or if you want x over time, whatever, that this here, oh wait, sorry, this is a v. Average speed equals distance over time. Well, average angular speed is going to equal theta over time. Again, if you look, so this is going to be 2 pi r over t. So if you look, and this is going to be 2 pi over t, well, I have to take this times r to get this. So v equals r times omega. And then you can do the same thing. If I take this divided by t, I get a. If I take this divided by t, I get alpha. So there you go. Okay. You, however, are not going to memorize this. You are going to think it through and always come up with the correct answer. Because if you memorize, you don't really understand anything, and then under pressure, you make mistakes. Where if you understand, you go, oh, I'm going to draw a circle. The distance is 2 pi r. My theta is 2 pi. So this theta times r equals d. Boom. Okay? And then once you have that, you can just say, well, d divided by t is v. Theta divided by t is omega. Boom. V divided by t is a. Omega divided by t is alpha. Boom. Okay? This is going to be your transition from one to the other. All right. There's your introduction. Bye, kids.